lenses, which is convex lens. It is also known as converging lenses. A typical thin lens consists of a piece of glass or plastic ground so that each of its two refracting surfaces is a segment of either a sphere or a plane. Lenses are commonly used to form images by refraction in optical instruments such as cameras, telescope, and microscope. So this is the focal length. Focal length is the image distance that corresponds to an infinite object distance. Next, this is the thin lens equation. Note that a converging lens has a positive focal length under this convention and a diverging lens has a negative focal length. Hence, the names positive and negative are often given to these lenses. When the object is in front of and outside the focal point of a converging lens, the image is real, inverted, and on the back side of the lens. Flat mirror. Images are formed at the point where rays of light actually intersect or where they appear to originate. The lateral magnification M is defined as image high over object high or H prime over H. In summary, the image formed by a flat mirror has the following properties. First, the image is as far behind the mirror as the object is in front. And second, the image is unmagnified, visual, and upright. By upright, we mean that if the object arrow points upward, so does the image arrow. The opposite of an upright image is an inverted image. Reflection and refraction are also some of the applications of physics in our daily life. For reflection, when a light ray traveling in a transparent medium encounters a boundary leading into a second medium, part of the incident ray is reflected back into the first medium. So there are two types of reflection, which are specular reflection and diffuse reflection. Specular reflection is the reflection of light from such a smooth surface, and diffuse reflection is the reflection from any rough surface. So the incident and reflected rays make angles θ1 and θ1 prime, respectively, with a line perpendicular to the surface at the point where the incident ray strikes the surface. We call this line the normal line to the surface. Experiments shows that the angle of reflection equals the angle of incidence, which is this. Traveling through a transparent medium encounters a boundary leading into another transparent medium. Part of the ray is reflected and part enters the second medium. The ray that enters the second medium is bent at the boundary and is said to be refracted. The incident ray, the reflected ray, and the refracted ray, and the normal at the point of incident all lie in the same plane. The angle of refraction, θ2, depends on the properties of the two media and on the angle of incidence through the relationship, which is sin theta 2 over sin theta 1 equals to V1 or equals to V2 over V1 equals to constant. Experiment shows that the path of a light ray through a refracting surface is reversible. So now we move on to the law of refraction. When light passes from one transparent medium to another, it's refracted because the speed of light is different in the two media. So this is the index of refraction. N equals to C over V, or N equals to speed of light in vacuum over speed of light in a medium. As light travels from one medium to another, its frequency doesn't change. So this is the Snell's law of refraction, which is N1 sin theta 1 equals to N2 sin theta 2. So that's all from us. Hope that you enjoy our video and learn in the best way.
Hey, thank you for watching our video. Physics in our daily life. My name is me.
My name is me. I'm Shreya. And my name is Aina Joa.
So, peace out.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left. The storms we chase are leading us, and love is all we'll ever trust. Yeah, no, I don't.
Hey, thank you for watching our video. This is our last assignment for this time. My name is me. And my name is Aina Joa.
Peace out.